students. I'm going to give you a quick rundown of activity 1.2, the wave lab that we're going to be doing in class. In case you are absent, you'll be able to see what we are doing. The only station you'll not be able to see here is test your hearing. We'll only be able to do that in class unless you look up a hearing test on YouTube. It'll start down at about 20 hertz and it'll run up to 18,000 hertz, and you can give yourself a quick hearing check if you'd like to. All right, station number 2, the standing wave creator demo. I am gonna pop in this is gonna cause vibrations in the string. I'm gonna pop this in, and what you're gonna see is what happens when we touch for the standing wave portion of it. We touch both the node and the antinode. So this goes in like that. It might be hard to see from on camera, but what will happen is it creates a standing wave, which is those infinity shape. So we have nodes down here, right there, and right there. Those are the places where there's not a lot of movement. And then we have antinodes here and here. That's where the string's going back and forth. It has a lot of movement, maximum vibrations. If I touch it at a node, it does not disrupt it very much because not a lot of vibrations, not much happening there. But if I touch it at the antinode, it kind of stops the whole thing, gets it out of whack. I have caused, there's already lots of vibrations there. Touching it at the antinode kind of stops the whole wave. Station 3 are water glasses. So I have 2 glasses right here. I am gonna cling them. This one has a lot less water in it. This one has a lot more in it. So you're gonna look to see which one makes the higher pitch. Lower, higher. The less the water, the higher the pitch. And I kind of give you some background on that in the bold for that. Station 4 are the boom whackers. Looking at boom whackers, I have 2 different lengths right here. So the pink one is a lot shorter than the orange one is. When I bang them, you will also, once again, hear different pitches. So the shorter the tube, longer tube, the longer has a lower note, shorter has a higher pitch. The variable that changes when you have different lengths, what's actually happening is you're setting up vibrations inside here with the air molecules, and the longer the boom whacker, the longer the wavelength that is inside of it for those to vibrate at. All right, so that is station 4. Station 5, these, we'll see if I can get one of them to sing for you. Sometimes they're good at this, sometimes. I don't know if you can hear it a little bit. It makes a little ringing noise, and that is called, I don't know if you can pick it up there, but what it makes is just a very slight ringing noise. You are making your wine glasses sing. That is resonance. I'm actually, when I move my finger around here like this, that was a good one. I am creating vibrations in the glass, which is then setting up what we're going to learn is called resonance. Those vibrations cause all the molecules to vibrate, and if you can get it to be the right amount of vibrations, it will actually cause sound to amplify, and it'll make it sing. Number 6, a standing wave with a slinky. Up and down, I am creating like a visual representation of a standing wave. If I have up and down, I have places called nodes. That's where my 2 hands are. That's where it's not moving very much. And I have the place that is the antinode. If you look at the slinky, you can see that in the middle, it's moving up and down, lots of vibrations. If I make it happen faster, I kind of have just stretched out and I have this infinity symbol. For my standing wave, I have created a 3rd node right there in the center, and I now have 2 antinodes. If I go really fast, you can get it to do it 3 times, and if you have a longer cord, or a longer slinky, you can get it to go a lot. But it's just seeing a visual representation of a standing wave. It's usually air molecules is where it happens a lot, but using a slinky to kind of see where the vibrations are a lot is the antinode, and at the edges where it's not vibrating much is called the node. Station 7, the sound toy from the dollar store. This is going to swing around, and you are going to hear it, once again, make a noise. I'm going to swing it normal, and then I'm going to swing it faster, and you're going to see what happens to the pitch. As the faster you swing it, the higher the pitch. Station number 8 is the dulcimer. I have 3 daughters at home. 2 of them have maybe dulcimers in school so far, so they are going to play with them. But what it is they have it. It's kind of like a 1-string guitar. So you put your finger in one space, and then you strum it down below, and then as you move further down, you are changing the wavelength. Alright, so as I move my finger down, I am getting closer, so I have a smaller wavelength, which then affects the pitch, so you're going to figure those out right there. And finally, the last one, I'm going to move everything out of the way because it's going to splash at me. I am going to take a tuning fork. I am going to vibrate it by hitting it against this activation block, and then I'm going to stick it in a cup of water, and what you are going to do is just see what happens. So I'm going to activate it, and what you can see is it splashes all over, and you should know that that has something to do with vibrations. We're creating vibrations within the tuning fork. Putting that into the water causes those vibrations to get transferred from one place to another. All right, that's it for the lab. If you were not there in class, hopefully that was enough to get you going. Thank you.